When we implement type unification, we take two types, T1, T2, and we also take an expression that's used only for error reporting. If we have to say that T1 and T2 are incompatible types, then we'll complain in terms of expert to give the programmer some hint about where things went wrong. Recall that our unification algorithm had two cases. Either T1 is a type variable or it's not, and in the case that it's not was the easier case. If it's not, then we look at type T2. If type T2 is a type variable, then we swap things around because we'll just handle type variables when they're T1. Otherwise, T2 is not a type variable, so it's either a num type or a bool type or an arrow type. If it's a num type, then T1, which is not a type variable, must also be a num type, in which case we succeed. If T1 is any other type, then we raise a type error saying that T1 and T2 are incompatible. If T2 is a Boolean, then similarly T1 also has to be a Boolean, and we can succeed. Otherwise, we raise a type error. If T2 is an arrow type, then T1 must be an arrow type. Otherwise, we complain. If it's an arrow type, then both of these arrow types have an A part, the argument part, and a result part. And we just make sure that the argument types are compatible and the result types are compatible by recurring with unify on their argument types and the result types. And we put these unifies in sequence with the begin because unify doesn't return anything interesting. It simply compares two types, perhaps assigning some type variables along the way, and then returns nothing if it succeeds, and it'll raise an error if it fails. So now we can go back to the case where T1 is a type variable. And in that case, is1 is a box that we look inside to find out whether this type variable has already been assigned a type. If it's already been assigned to a type T3, then we just use T3 in place of T1 and recur. Compare that again to type T2. Otherwise, T1 is a type variable that has not been assigned before. So we need to take T2 and resolve it to get the most information we know about it right now. T2 might be a type variable, and so we want to get whatever that's been equated to transitively following equivalences. Now if T3 turns out to be T1, the type that we started with, then in that case we've succeeded. We've just checked that T1 is T1, that holds, there's nothing new to record, we only succeed. Otherwise, we need to make sure that T1 does not occur inside T3. So we use an occurs check. If T1 does occur inside of T3, then we can't equate T1 and T3, and we have to raise a type error. But if T1 does not occur in T3, then we can just assign T1 to be the same as T3. That is, we set the box, is1, which was inside T1, to sum of T3. And then we return nothing in particular because unification has succeeded. If in the future T1 is used again, then we will end up noticing that it has some assignment T3, and we'll recur with that T3 in the future. Here's our helper functions resolve and occur. Resolve just finds type variables and recurs through type variables as long as they have some assignment. As soon as we have a type variable that doesn't have an assignment or any other kind of type, we just return it, whereas recur goes through looking for a type variable that's equal to the one that we have.